morning children. In today's class we are going to learn exercise 4.5 in which second order differential equations are given. dy by dx implies first order. I differentiate once. D square y by dx square implies I differentiate twice, so it becomes second order. So in today's exercise, we will be having d square y by dx square, also dy by dx and some terms with y. So when you are having a pattern like this, wherever this d by dx is coming, let me put capital D. D square by dx square is coming, put capital D square. So this is an equation. A, d square y by dx square, b, dy by dx plus cy equals to 0. I rewrite this as this d square y by dx square, capital D square, d by dx, capital D, and c. In all, I am left with y that is equal to 0. Now, take this, solve for it. When I solve, I mustn't have the differential coefficient in my equation. So, wherever d comes, put m. Wherever d square comes, put m square. That equation I call auxiliary equation. The equation that helps me in solving. So, auxiliary. And I write the equation a m square plus b m plus c equals 0. Mustn't write y, only I am solving the factor that is inside the bracket. So, as I write the auxiliary equation, I am able to solve because it is a quadratic equation in m. When I solve it by factorization or formula method, I get two roots, say m1 and m2. The two roots may be equal, unequal, or even complex number, that is imaginary number. Based on that, I write complementary function, that is the solution for the LHS. So how do I write the complementary function? When the roots are different, a e power first root into x plus b e power the second root into x. The roots I can change and write also. Suppose 5, 7 is there. I can write 7, 5. There is no order in writing m1 and m2. Next, suppose the roots are equal. Say m, the second root is also m. In that case, my complementary function will be ax plus b into e power mx. I can also write a plus bx into e power mx. Both are correct. What we should remember, one constant with x and one constant without x. Either it is a plus bx or it is ax plus b e power the single number that I get in my solution into x. E power I must write. Mustn't mistake, don't write near. Ax plus b inside the bracket, e to the power whatever number I get into x. So this I call complementary function, in short CF. In the previous exercise we had IF, integrating factor. Now we are writing CF, complementary function. They all come in the same chapter but mustn't confuse while writing. Next I have the roots may be alpha plus or minus I beta. That is imaginary. Inside the root I get negative number. Suppose I have root of minus 4. I write, whenever minus is inside the root, we write 4 square root is 2. So my question is like this way. 12 plus or minus root of minus 4 is coming. My answer will be 12 plus or minus. This minus inside the root gives me I and 4 square root is 2. Remember, Negative number inside the square root gives rise to imaginary called I. Suppose my answer is of this format. This 12 I call alpha, this 2 I call beta, and now the complementary function is e power alpha x into a cos beta x plus b sin beta x. Now all this pertaining to the LHS, left hand side. Right hand side may be coming like this way, e power ax. Suppose e power ax is coming. How should I write the RHS? The RHS solution we call particular integral. Again, in short, I can call it as PI. How to write this PI? E power ax divided by, for example, I have like this 2d square plus 3d minus 7, something like this. Instead of ax, 2x is there. Wherever d is coming, put this number. Wherever d square is coming, put the square of it. This is an easy solution to write the RHS provided the denominator doesn't become 0. So in the exercise problems, we will see all these things in detail. Such an easy exercise. So everyone can try and learn, and mostly a question is repeated in all the exams. Exercise 4.5, question number 1, d square y by dx square minus 6 dy by dx plus 8y equals to 0. Our first step is to rewrite, writing this as d square minus 6d plus 8 y, that is common, will be written after the bracket, equals to 0. So we have to write auxiliary equation. How to write the auxiliary equation? D square becomes m square, d becomes m, constant as it is, should not write y, only the bracket, only the quadratic factor I am writing. Solve for it. How will you solve? Factorization will help me. 8 and I want minus 6. 4 2s are 8. Because minus comes minus, so together minus 4 minus 2 is minus 6, minus into minus plus, 4 2s are 8. So I get m minus 4 into m minus 2 equal to 0, that is m equals 4 comma 2. The roots are real and different. They are not the same. 4 and 2 are different. How will you write the complementary function? It is a e power m1x plus b e power m2x. So the complementary function is a e power 4x plus b e power 2x. Since the RHS is 0, particular integral, that is a solution for RHS, is also 0. So I will write the general solution, or I can write the complete solution, is nothing but y equals CF plus PI. Y equals CF is a e power 4x plus b e power 2x. Pi is 0, so we'll ignore it. This is my answer. Now see, instead of 4 and 2 here, I can also write 2 here and 4. There is no rule which number should come first, second, all that. One constant into e power one number into x plus another constant into e power another number into x. So that is the answer. Exercise 4.5. Question number 2. Solve d square y by dx square minus 4 dy by dx plus 4y equals to 0. We rewrite the question. D square minus 4d plus 4, the whole thing into y equals 0. Our step is to write auxiliary equation d square as m square, d as m plus 4 equals to 0. As I solve 4, I need minus 4. The only options are minus 2 and minus 2. So we get m minus 2 into m minus 2 equal to 0, or m is equal to 2 comma 2. The roots are real and equal. So we remember the formula. When they are real and equal, complementary function is equal to ax plus b e power mx. Here m is 2. And RHS is 0 implies particular integral is 0. RHS 0 implies particular integral is 0. So here I get ax plus b e power m is 2. So my answer is 2x. Now I write the complete solution. The complete solution is, or I can say the general solution, is nothing but y equals CF plus PI. CF is AX plus B e power 2x. PI is 0. So this is the answer. Question number 7. D square y by dx square plus 16y equals to 0. We rewrite the problem. D square plus 16 into y equals to 0. We write the auxiliary equation m square plus 16 equal to 0, or m square equals minus 16. M is equal to root of minus 16. Whenever negative comes inside the square root, we write I. 16 square root is 4. So we go on to the third model. These are called complex roots. What pattern we say? Alpha plus or minus I beta. In my question I have whenever root comes plus or minus, minus inside the root implies I. 16 square root is 4. So I get plus or minus I4. No real part is there. That is no alpha here. So call it as 0. Comparing. Alpha is 0 and beta is 4. And we have the formula for the complementary function. It is e power alpha x into a cos beta x plus b sin beta x. As I substitute in the formula, CF is equal to e power, what is alpha? 0, x, a cos beta is 4, a cos 4x plus b sin 4x. E power 0, anything power 0 we say 1. So e power 0 is 1, forget it. CF is equal to a cos 4x plus b sin 4x. The RHS is 0 implies particular integral is 0. We write the general solution. The formula is y equals CF plus PI. Here CF is a cos 4x plus b sin 4x. Pi is 0, so ignore that part. This is the solution. Question number 3. D square plus 2d plus 3 into y. Our first step is to write auxiliary equation. M square plus 2m plus 3 equal to 0. Solving 3, we get 3 ones are. Will you be able to solve? No. So in this case, I have to go on with the formula method. No number 1, I call this as A, this is B and this is C. What is the formula? Minus B plus or minus root of b square minus 4ac by 2a minus b value 2 plus or minus b square is 4 minus 4a value 1 c value 3 divided by 2 again a value is 1. Simplify this. Minus 2 plus or minus root of 4 minus 12 divided by 2, or it is minus 2 plus or minus 4 minus 12 is minus 8 by 2. Whenever negative symbol is inside root, I call it as I. Root 8 can be written as 4 into 2. So root 8 means it is root of 4 into 2. That is 2 root 2 divided by 2. All the 2's will get cancelled. So my answer is minus 1 plus or minus I root 2. I divide by 2 every term. So my answer is minus 1 plus or minus I root 2. Now we put it in the complementary function. What is the formula? The roots are complex. What is the format? Alpha plus or minus I beta. In this question, minus 1 plus or minus I root 2. Compare. Alpha is minus 1. Beta is root 2. And we know the complementary function is e power alpha x into a cos beta x plus b sin beta x. Just substitute for alpha and beta. Minus 1 into x minus x, a cos root 2 into x plus b sin root 2 into x. We write the general solution as there is no RHS. Y equal to e power minus x, a cos root 2x plus b sin root 2x is the answer. We generally write CF plus PI. Whenever RHS is 0, y equal to CF alone is the answer. Question number 4. Solve d square y by dx square, which I write d square, 2k, this I call d plus k square, the whole thing into y equals to 0. We write the auxiliary equation m square minus 2km plus k square equals to 0. Solving k square, I need minus 2k. So it will be k into k. Minus symbol tells me minus minus. Check whether it is right. Minus into minus plus. K into k square. Minus k gives me minus 2k. So my answer is m minus k into m minus k equals 0, or m is equal to k comma k. K is just a number. Do not get confused. It's just a number like 7, 8 like that. So m is having k and k. So I will say real and equal roots. Whenever the roots are real and equal, complementary function is ax plus b e power mx. Here complementary function is ax plus b e power kx. And we write the general solution. The right hand side is again 0. CF plus PI, y equals AX plus B e power KX. RHS 0 implies particular integral is 0. So our answer will be y equals AX plus B into e power KX. Question number 5. Solve d square minus 2d minus 15 into y equals 0. They have given you certain conditions which helps us to find what is a and b in the question. Let us proceed in the usual pattern. We need to write the auxiliary equation. D square will become m square. D will become m. Minus 15 equal to 0. Solving minus 15 and I need minus 2. 5 3s are minus represents bigger number is minus. m minus 5 into m plus 3 equals 0. M is equal to 5 and minus 3. I will say the roots are real and different. So the complementary function is a e power m1x plus b e power m2x. So we get a e power 5x plus b e power minus 3x. Since RHS is 0, we get the general solution y equals CF plus PI, or I write y is a e power 5x plus b e power minus 3x. Call this as 1. Generally, our answer is over, but they have given you some conditions. dy by dx, d square y by dx square. So, dy by dx implies, let us differentiate this. Y becomes dy by dx. A e power 5x. The derivative e power 5x is e power 5x. 5x will become 5. B e power minus 3x is e power minus 3x. Minus 3x implies minus 3. Remember, in differentiation, I put the number near. In integration, I put the number in the denominator. Now, this let me call number 2. Now, I need one more derivative because they have given d square y by dx square. So, dy by dx, when I differentiate, dy by dx will become d square y by dx square. It is already 5a. E power 5x will become e power 5x into 5. Again differentiating. Minus 3b will come as it is. E power minus 3x will become e power minus 3x into minus 3. This is nothing but 25a e power 5x minus into minus plus 9b e power minus 3x. Call this as number 3. Now, let us substitute the conditions. What are the conditions given? dy by dx equal to 0, x is equal to 0. Second equation implies dy by dx 0. The formula is 5a e power 5x will become 0. Minus 3b e power minus 3x will become 0. And we know e power 0 is 1. So we get the equation 5a minus 3b equals to 0. Call this as number 4. What is the second condition of the question? D square y by dx square equals 2 when x is equal to 0. Put it in the third equation. What is third equation? D square y by dx square equal to 25a e power 0 plus 9b e power 0. This implies 25a plus 9b equals to 2. Call this as fifth equation. Now, I must solve fourth and fifth equation. Fourth equation, let me multiply by 5 or let me multiply by 3. Fourth equation, multiply by 3. 15a minus 9b equal to 0. Fifth equation we write as it is. 25a plus 9b equals to 2. Adding 9b and 9b cancels. 40a equals to 2. I am just adding. Implies a equals 2 by 40 or it is 1 by 20. Put a value in fourth equation. Put a equals 1 by 20 in fourth equation. As I substitute 5 into 1 by 20 minus 3b is 0 or 3b equal to, I can cancel this, 1 by 4. b equals 1 by 12. Now I know what is a value and what is b value. Put them back in first equation. So that is the expected answer. So what is the first equation? Y equals a e power 5x. A value 1 by 20 e power 5x plus b e power minus 3x. B value 1 by 12 e power minus 3x, and that is the answer. In the other problems, we stopped with this step. But in this question, since they have given some conditions in the question, use it, solve it, find what is A and B. Put A value and B value back in equation 1, and that is the answer.